Okay, welcome everyone. Good morning, good evening, good afternoon, wherever you are in the world. Thanks very much for joining us, and thanks so much for being part of our tech community as well. My name is Ricky Simpson. I'm the product market manager for Microsoft Defender for Identity, and I'm going to be your host for today. But a few reminders before we start and hand over to our fantastic webinar presenters today. If you have any issues viewing the stream at any time during the presentation, and you're using a web browser version of Teams, please just refresh your browser. And if you're using the desktop app, obviously the standard exit the meeting and rejoin is the best port of call for troubleshooting 101. So please note that this webinar is being recorded and it will be shared publicly. We'll post the recordings in our community at aka.ms/security webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask any questions at any time by leaving them in the live event Q&A window and by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box below where you enter it. We do often get many questions on these webinars, and we'll do our best to respond to all of them in real time. In the event that your answer wasn't provided in time, or if you have additional questions after this event wraps up, then please don't hesitate to raise them in our Defender for Identity discussion forum, and that can be found at aka.ms/MDI community. And if you're listening to this after the fact as a recording, that's also a great place to ask a question if you have one that wasn't addressed on the webinar, if you have anything specific that's on your mind. We also love to hear your feedback on how we can improve these webinars, and you can provide that feedback at aka.ms/security webinar feedback. And I'd also like to invite you to our more broader public security community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. And on our community, you can speak directly to engineering teams that create our security products, and you'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, request features, give feedback, review our product roadmaps, register for events like this. And we believe that it's the best way to improve our products is by removing any barriers between you and the people that create them. So we very much hope that you'll join us there. All of those links that I've mentioned, I've also published in the Q&A for your convenience too. So today's session will be led by Shirin Meljon. She is a senior security researcher. So Shirin works in our incredible security research team and is going to guide us through a researcher's point of view when it comes to identity targeted attacks and how we use this industry-leading research to make detections available for Microsoft Defender for Identity with next to no lead time based on when a vulnerability is disclosed. And so without further ado, I will turn it over to her. Shirin, the floor is yours.
Thank you, Ricky. Thanks for the introduction. Hello, everyone. So again, I am a senior security researcher for Microsoft Defender for Identity. My name is Shirin. I joined Microsoft 7 months ago, and in my previous roles, I used to be an incident responder. So a lot of the things I'm going to talk about today are things that I actually saw in the real world on real customer environments. So let's begin. What we're going to cover today is briefly talk about what are identity attacks and why do they matter. And then we're going to go through an attack story that I constructed that will include demonstration. And we will see what are the MDI detections that are generated for each phase and each attack in this attack story. After that, we're going to wrap up with a few anecdotes about Conti ransomware group that is known to be AD focused group. And we will see that the attack story that I constructed really holds up in the real world. So let's begin. What are identity attacks? So these are attacks that are focused on compromising identity or identity infrastructure. And we have to remember when we're talking about identity attacks that the identity is the means, it's not the actual goal. So I would like to, if I'm an attacker, I would like to compromise identity or identity infrastructure in order to read emails or access sensitive information, or maybe modify it, disrupt it, or encrypt it. So the identity would be the means for me to achieve the attack objectives. And when we are looking at the entire identity landscape, when we look into that, we have enterprise network or Windows enterprise networks that are normally managed by Active Directory and domain controller servers. And we noticed that domain controllers are a main target for attackers, as being dominant in the domain would allow attackers to effectively achieve the attack goal. So we know that this is a main target for them. And because of that, new vulnerabilities and attacks are constantly being explored and discovered in order to compromise this infrastructure. And what's interesting about attacks on managed network or domain networks is that it requires some interaction with a domain controller. So whenever I use an identity that is managed by a domain, or I modify an identity that is managed by the domain, some evidence will appear on the domain controller. So for MDI to be deployed on domain controllers, we are able to collect and have unique signals that apply to the entire domain, and basically be able to detect the attack and the attack path just by being deployed on this central location on the domain controllers. Okay, so now we're going to go through the attack story that I constructed, and I love this story because I think it really demonstrates the value of MDI. And how we detect the identity threats as opposed to other security products or security categories, for example. So before we start talking about the attack story, let's have a look at the network that is being compromised. So we have a common enterprise network that is domain managed. We have the domain controllers. We have also servers that might be DBs or file servers or backup servers even. We have the endpoints here that are also managed in the domain, and the internet-facing servers. And as we noticed in the past few years, work from home and remote access to the network has become more and more common and prominent. So employees are going to be able to connect to the network and access a network resource using VPN. And in our story, we have an attacker that is accessing the network, infiltrating the network using VPN credentials that are compromised. So just to clarify, this attacker machine is the attacker's machine. It's not a domain managed. It does not have any security product deployed on that machine, and just connecting to the VPN and to the network with a user and password. This user and password could have been compromised in multiple ways. It could have been guessed, brute forced, and even bought in the dark web, for example. So this is our starting point. And we are going to go through the entire kill chain from discovery to privilege escalation, credential access, lateral movement, and eventually persistent. And this entire flow is going to happen only against the domain controllers, and I will not touch any other asset in the network. So this will definitely highlight how, by monitoring this central location, you can detect this attack from early stages, from the discovery phase to the persistent phase. So let's begin. Let's start with the discovery. So for each attack phase that I'm going to describe and go through, we will see what is the current foothold that the attacker has and what is the objective that we're trying to achieve. And the initial foothold, as I mentioned, is the VPN access. And the VPN access is made with a weak domain user account. We can see it here on the bottom right, user 1. My first objective is to identify the best path for domain dominance. This is a new network for me. I don't know anything about it. So let's try to collect some information. I'm going to use ADefine to run LDAP queries and collect information about domain groups, domain accounts, what are the privileged accounts, and what are the workstations and servers of interest to me as an attacker. So let's go to the demonstration here. Okay, first I'm going to show that I'm on the attacker hostname. So let's run the hostname command. So this is my hostname attacker. I am the local administrator on my machine. I am not a member of the domain. Next, I'm going to do NSLOOKUP command on the domain. This will provide me with the IP addresses of the domain controller. This is the first piece of information I'm going to collect. And just to make sure that I actually got the IP addresses of a domain controller, I'm just going to select one of these IP addresses and ping it in order to see the computer name. And we see here that I got DC4 and I already know the IP of DC1, and I can already tell there is some sort of naming convention, for example, here. And I understand that I got the list of IP addresses of the domain controllers. Next, I'm going to use this information and the ADefine tool in order to query, to perform some LDAP queries and get more information about this domain that I just compromised. Okay, so the first command will be to get information on all user accounts. And you can see here, if we go through the command line, that I'm targeting DC4, I believe. This is the IP address. And I'm using the credentials of user one. This is the weak user account that I used to enter via the VPN. This is the only account that I have that is compromised at the moment. I'm querying all the users, and I'm saving it to a text file. And simply by looking at the password, I mean, you can tell that it was probably yes. It's not a very complex password or secure password. Next, I'm querying the computers and saving it into a separate file of all the domain computers and groups. And of course, I'm going to run the organizational unit. What I'm going to do with all this information is analyze it and find the best way or the best targets for me to compromise. You can see here that I queried also the domain administrator just to know what they are. This is a lab setup, so you can see there is a victim user account, but also administrator. And next, I'm going to query all the enterprise admin. This is another privileged group that I want to see who is a member of this group. And now that I have all that information, let's have a look at the output that we have. So here we have all the domain users. You can see here the administrator, for example, and all the attributes of these domain objects. And if we look at the computers, we also have all the computer accounts that exist in this specific domain, in this Active Directory, and I can learn a lot about all the information. So this is basically the first step. And let's talk about the detection that is available in MDI. So MDI, as I said, is deployed on the domain controllers. And by doing that, we are able to monitor and parse and process the LDAP queries that the domain controller receives. And the thing about LDAP queries, and this is really the detection challenge here, is that this is a normal and legitimate activity expected in a domain environment. This is normally a legitimate activity. And the challenge here is to differentiate the legitimate activity from the malicious reconnaissance activity. So MDI implements several detection logics that include learning and baselining of every environment. And we are able to alert on an enumeration activity that is unusual for that environment. And here we can have the details of the alert. We can see that from the attacker machine, there were several LDAP queries sent to DC1 with 4 types of enumeration. And I also have the details of the enumeration, all computers, all groups, all users, all accounts. So this is the alert in MDI. The next phase is to get better privileges. So now I have the VPN access, the weak domain user account, and some domain information. The next thing I want to do is to obtain the certificate of a domain controller machine account. You might ask yourself, well, what can you do with the certificate of a domain controller machine account? And this will be revealed later in this attack story. But let's just assume that this is what I'm aiming for. So now I'm going to review a DNS hostname vulnerability. This vulnerability was discovered a few months ago, and since then it's been patched. So we're going to talk about it in past tense. So let's see how it works. A certificate in Kerberos authentication can be configured instead of passwords, so it can be used for biometrics or smart cards or other scenarios, just instead of a password. And the certificate are issued by a certificate authority. That's normal. And Microsoft implementation of a certificate authority is the ADCS server, the Active Directory Certificate Services. So how the certificates are issued in the AD environment? Each entity in the domain can request the ADCS for certificate issuance. So just by having this weak domain user account, I can request for a certificate. What happened before the vulnerability was patched is that the ADCS looked at the attribute of the DNS hostname of the requesting entity and provided the certificate according to this attribute. So how did the vulnerability work? First, I can create a new machine account. So just by having, every user account in the network can do that. I can create a new computer account. And this could be harmless, but then I can change the DNS hostname attribute to be DC1. So for example, you can see here that I created fake computer and I changed the DNS hostname attribute to DC1. What happened is when I enrolled and requested a certificate from the ADCS, it was issued to DC1 according to the DNS hostname attribute. So this was the vulnerability. And this way I have obtained the DC1 certificate, and we will see what I can do with it next. But before that, let's review the detection. So interesting story, the first indication for this vulnerability was received by Microsoft via MSRC cases prior to the vulnerability being publicly disclosed. This means that we were able to provide detection to the customers from day one, alongside with the OS patch and a blog post. So this is pretty cool. And you can see in the snippet in the bottom of the blog post written by Eran, which is a team member of the research team that I'm a member of. And let's talk about the detection. So you can see here we have the first detection is suspicious modification of a DNS hostname attributes. So MDI actually monitors all changes of the domain objects and is able to tell when the DNS hostname attribute was changed to be that of a known domain controller. So what we can see here in the alert is that user 1 created fake computer, this is the computer account, and set it with the DNS hostname of DC1. DC1 is a known domain controller in this environment, and this is why we alerted on it. But as I said, this vulnerability was patched, and we wanted to also have a more generic detection for this type of malicious activity. ADCS is a very hot topic right now, and new vulnerabilities and misconfigurations are constantly being explored and exploited by threat actors. So today, the DNS hostname vulnerability is patched, but tomorrow there could be another vulnerability that we are not aware of. And this is why we have another detection that alerts on any use of a domain controller certificate not originating from a domain controller. So we can see here that the additional detection that was generated is that attacker, this computer account, used the certificate of DC1 and attempted to authenticate with it. And this in itself is already suspicious. even without the changes in the DNS hostname attribute. So we all ask ourselves, what can you do with a certificate? And the answer is DCSync attack. So what we have so far, again, let's review it: VPN access, the weak user domain account, and the domain controller certificate. Now the objective that I have is to obtain the KRBTGT password hash. This is like, I'm going for gold, I'm going for a highly valuable target. If I get that, I'm going to be dominant in this domain. So this is a very critical asset to achieve as an attacker and to protect as a defender. And how do I do that? Using DCSync attack. DCSync actually takes advantage of legitimate and necessary function between domain controller. This function is called directory replication. And what it basically means is that, you have several domain controller servers. They all have a state of the Active Directory. And for example, I might create a new user account, or I can change and modify an existing object in the Active Directory. And this will happen against one of the domain controllers, but I want all of the domain controllers to have the same information, the most updated information about the Active Directory. And this is why basically they replicate and sync between them. And this is a needed function in the domain. But if an attacker has any object or any entity identity that has domain replication privileges, they can also request for replication because they have those privileges. And for example, if I have the DC, the domain controller certificate, I will have the domain replication rights and privileges, and I will be able to ask for replication. So how does MDI detect this attack? We monitor, again, we are deployed on the domain controllers, and we monitor all the replication requests that are sent to the domain controllers. And we're able to alert on replication requests that are not originating from the main controller machine. So here you can see in the alert, suspected DCSync attack. And what's interesting here, and it really pops up immediately, we can see that DC1 attempted or made replication request from attacker computer account to DC1. So this doesn't make sense, but even if it was a different entity and this replication request was not originating from a domain controller, we would alert on that. And here, I mean, this way I get the password hash of the KRBTGT, and I want to emphasize that up until now, which is a very advanced phase in the attack, I did not touch any other asset in the network except for the domain controller. And all the tools that I'm using on my machines are not monitored, because if I run, for example, Mimikatz on attacker machine and there is no EDR on that machine, I mean, no one can stop me from executing that. And this is, I think, really emphasizes why being located in this central location is really valuable for this attack story. So now we're going to review the demonstration of DNS hostname vulnerability and DCSync. So first thing I'm going to do is I want to see if this network or this domain has an ADCS server. The way I'm going to do that is query the cert publisher group in the domain. And here I can see that DC1 is the ADCS server. So in this specific network, what happened is the role was added to one of the domain controllers. Now that I know that there is in fact an ADCS and I know its identity, I will see if the computer that I'm trying to create exists in the domain. And I can see that it does not. So, I mean, I could have already known that using the whole discovery phase and output that I had, but I just wanted to show you also that this computer does not exist. And now what I'm going to do is use this Python script in order to create fake computer and set it with the DC1 DNSHostname attribute. And I'm doing so using the weak domain credential that I have from the beginning. This is really the only asset I have so far. Okay, after I run this script, I can see that I successfully added a machine, fake computer, and I have also the password of that computer. And this is again one of the goals of me creating this computer account so that I can have its password as well. And it was also set to DNSHostname DC1. Now let's query it in the Active Directory. It does exist. It is named fake computer, fake comp. And we can also see that the DNSHostname attribute is set to DC1. So this was successful. The next thing I'm going to do is use Certify. Certify is a tool that is used for certificate operations. And I'm now going to request a certificate for fake computer. And I'm going to use the password that I obtained from creating this computer account in order to request the certificate. Here you can see a tiny error that I made. I did not enter the password after this location in the command line, so you're gonna see me struggling here. But then I fix it, so it's gonna be okay. Okay, now I'm going to put the computer password in the right location in the command line. Yeah, and it worked. Now I have a certificate for DC1 saved on my computer. Now let's have a look and verify that it was in fact issued to the domain controller, to DC1. The way I'm going to verify that is I'm going to look at the subject of the certificate and see that it's set to DC1. Let's just open that certificate. Yeah, and I can already tell it was issued to DC1, but just like to be very accurate, let's go ahead and look at the subject. Yep, so this is, I actually have the domain controller certificate on my computer in my possession. So the next step I'm going to do is I want to get the password hash also of DC1 for the DCSync attack. And the way I'm going to do that, I'm going to authenticate with the new certificate that I have. And as a byproduct, what I will get is the actual password hash of DC1. So this is the next step I'm doing, and this is a critical piece of information that I'm going to add to my attacker notepad. I could not have achieved this password hash otherwise, so this is part of the attack. And the next thing is going to be the DCSync attack. So I'm going to use secret stump and use the password hash that I just recently obtained and target DC1 in order to replicate the entire identities in the domain. So you can see this is running and working, but I don't need all that information. What I really want is just the KRBTGT password hash. So usually in the beginning. And yeah, let's copy that. I can't stress enough how valuable and critical this piece of information is and how advanced this attack is once I already have it. Okay, so this is it for this demonstration. Okay, so now we have three phases left, so bear with me for this attack story. We have the golden ticket, then we have the remote code execution, and finally we will have the persistence. So let's see what I'm going to do with the KRBTGT password hash. I would like to now authenticate and access additional domain resources, but I want to do that as a privileged user account and not as user one or as a computer domain controller account. So how can I do that? The way golden ticket attack works is it utilizes the way Kerberos authentication works. And Kerberos authentication is based on tickets. These tickets are, and I'm really like simplifying it, I'm sorry, but these tickets are granted by the domain controllers and they are assigned with the KRBTGT password hash. So for example, if I, as an attacker, have the KRBTGT password hash, I'm able to self-generate a valid Kerberos ticket to any account with any privileges that I would like. And the domain controller will accept it because it is signed with the password hash that it knows. And the next thing that I will do once I have self-generated this valid Kerberos ticket is that I will present it to the domain controller in order to request for an additional ticket to access other resources in the domain. So basically, if I only have the ticket that I self-generated and I did not present it to the domain controller to obtain an additional ticket, no harm, no foul. I did not access anything real. So this is a critical part of the use of tickets. And let's see how we detect this attack. So we are able to monitor all the tickets that were generated by the domain controllers and all the tickets that were presented to the domain controllers because we are deployed on them. And the way we detect it is that we search or we identify when the ticket that is presented to the domain controller was not actually issued by the domain controller. And this is how we know it's self-generated. We have several flavors of this detection with additional anomalies and logics. And what I used in this demonstration is a non-existent account to show you how powerful this ticket is. So I can actually generate a ticket that for a user that does not exist in the Active Directory. There is no bad user one in this environment, in this domain. However, it still has domain administrative privileges just because I have generated a relevant ticket using the KRBTGT password hash. So you can see here the non-existent account was triggered, and this is basically the alert. The next thing I'm going to do with the ticket that I generated, I would like to run code remotely on the domain controllers. And how I'm going to do that, I'm going to use PSEXEC, a simple tool used for remote code execution. And we are also able to detect that. There is a little point to mention here about this detection is that it's only relevant for PSEXEC execution on domain controllers because this is the only way we are able to, the only location we are able to monitor the processes and the services being created. So just using PSEXEC and the ticket that I generated before, I can run code remotely. You can see here the alert from attacker, this is my machine, to DC4 in this example. And the last step, I want to gain persistence in the domain. Right now, my foothold is I'm completely dominant in this domain. I own it. I can access any resource that I would like that is managed by this domain using the KRBTGT and the golden ticket attack. But I mean, I worked hard to obtain this access and this foothold, and I want to remain dominant in this domain. And this foothold that I have could change, for example, if the compromise is discovered by the security team and they decide to rotate the KRBTGT. So the password hash changes, and then the vulnerability is patched and I can no longer use the DNSHostname vulnerability. And maybe the one user is disabled and the password changes. So I can basically lose the entire foothold that I have. And I want to create redundancy and some persistence. So the way I chose to do that is to create an additional user account. And that user account will be an administrative user account, because why not? So how do we detect this type of activity? And again, this is interesting because to add user to the domain administrator groups or any other privilege group could be a legitimate activity. This is how you operate in a domain. So how do you differentiate between legitimate addition to privilege group and malicious addition? So basically, we monitor all the group membership changes, and we use several logics that, again, they use baselining and learning in order to detect an anomaly, an anomalous user being added to the domain admins or privileged groups. So what do we see here in the alert? Suspicious addition to sensitive groups. And we can see that bad user 1, which really it does not exist in the domain. However, it is still able to add bad admin, which I created, to the domain administrative group. We have additional evidence here. We can see that it happened from the attacker machine, because in the past 2 days, this user was observed in this computer, and we can understand basically what was the path. So this is our final demonstration, the golden ticket and remote code execution and persistence. So let's have a look at that. Okay, so I still have a piece of information missing in order to perform the golden ticket attack. I need to get the domain SID. So I'm going to use the lookup seed tool script and use, again, the password hash of the domain controller that I had before, and run this command, and I will get the domain security ID. Here also you can look at these security IDs, identifiers. You can see that administrator would be 500 and domain admins will be 512. And we will go back to that information later and see that these are the privileges that I would like to get with my golden ticket. Now, after I copied the SID, the domain SID to my notepad, I would like to demonstrate that if I try to list files on C drive on DC4, I'm not able to do that because I don't have the correct privileges. So what I would like to do is to create the Kerberos ticket, the valid Kerberos ticket with the right privileges in order for me to be able to run code on DC4. So I'm going to use Mimikatz for this attack. Mimikatz has a module for golden ticket. Let's review the command line that we have here. So I'm using the Mimikatz module for golden ticket, and I'm generating a ticket for bad user 1, which, as I said, does not exist in this domain. I'm setting the domain to be this environment domain using the SID that I gathered before, that I collected before, and I'm using the KRBTGT password hash. This will also load the ticket that was generated into my session, so I will already have the right privileges. And we can see that it was successful and the ticket was submitted to the current session. So now I can just like exit Mimikatz and carry on with the attack. If I try to list the C drive on DC4 now, I am able to do that because I have the ticket and I have the right privileges. Okay. By default, if I don't set any other parameter, Mimikatz will create the ticket on the domain administrator group privileges. So this is what happened here. And now I'm going to run PSEXEC remotely on DC4 and open CMD on DC4 so I can run commands on that server. Starting the service takes a few seconds. Great, so now I have CMD on DC4. Let's see that it's true. Hostname DC4, and who am I? I am bad user 1, which is a member of the domain. And now the next thing would be the persistence. I would like to create bad admin user and add it to the domain administrator group. So the first thing I will show that the user does not exist, and then we will create it using a net command. It was added successfully, and now we will see that it does exist in the domain. However, I do have one last step. I want to add it to the domain administrator group. So first, let's see who's a member of this group. We can see the administrator, the victim, and so on. And now I'm going to try to add it to the domain administrator. I made a tiny typo here. It's not bad admin 1, it's bad admin. So let me struggle with this until, yeah. So now we're going to run the command again, but with the correct username. And it was completed successfully. Let's see what are the users that are the members of the domain administrators. Yep, and bad admin is here, and I have some sort of persistency in this network. So this is it for this attack story and the demonstration that we have today. Let's see here how this attack would look like in MDI timeline in the console. So it goes from earliest to latest, and we can see that we are able to generate detection from very early stages of this attack to very late stages of the attack, in very advanced phases of the attack. And there's a few things I'd like to mention about the attack here, is that, again, all the work was done in the entire flow against the domain controllers. But this is not the end of the story. I mean, it's the end of our story today, but I mean, the objectives of the attack is not to be domain dominant. The objective could be maybe accessing sensitive information or encrypting or whatever. So from this point on, there will be some access to additional assets in this environment and in this domain. And other evidences will appear on EDRs, for example, or other security products when this will happen. However, if you only detect the attack at this point, after the attacker is already dominant in the domain, it's a very late phase to detect and to try to remediate and mitigate the attack. So this is it for this story. Okay, let's talk about the data sources that we are using in MDI. Again, our sensors are deployed on the domain management server. This includes domain controllers and ADFS. And we're collecting the network events, event logs, and Active Directory objects and data. And we are authoring the detections according to that, or based on that information. Here we have the detailed list of all the detections that we have currently in MDI according to the attack phase or the phase in the kill chain. And what's interesting to say here is that for each of these phases, we are looking at the identity angle. So for example, if I'm looking at persistence, this is not OS persistence, for example, this is identity persistence. So this is the scope that we are focusing on with MDI. Okay, so this was a nice story, and let's see if it really holds up in the real world. So I'm going to share a few anecdotes about Conti, their ransomware group, and these anecdotes are based on a recent data leak that they had. So what happened, and this is the background of the data leak, is that after Russia invaded Ukraine, Conti, which is affiliated with Russia, published some sort of statement saying that they fully support the Russian government and they will retaliate if any cyber attack or any activity against Russia will be made. Apparently, one of the members of this group was Ukrainian or had some sort of affiliation with the Ukraine, and they were very offended by this statement, which was removed and revised, let's say, a few hours later, but it was a little bit too late. They were already offended and decided to leak very sensitive information that give us a very unique insight on how Conti Group operates. And the leak included communication logs and organizational structure and training materials and methodology. Very, very unique insight into this operation. So what do we get from that data leak? We can understand that Conti really works like a small company. They have hierarchy and they have team members, like team leaders. They have several physical offices they operate from. They have training documentation and methodology, like a very organized methodology for their operation. And also that they struggle to recruit and retain talent. So really like a small company, pretty remarkable insight. And if we look at the methodology that was exposed, we can see that they are in fact highly focused on Active Directory-based network. This is from their training materials. You can see the primary target of most attacks is the Active Directory domain controller or domain controller of the Windows network. And to sum up, and this is again from the training material, to sum up the methodical process that they are working with is to, from a single point of access in the network to discover what you have around you, and then try to dump the credentials and try these credentials on additional assets that you see around you. And again, and go back to one. So discovery, gaining the new credential by dumping them or brute forcing them, laterally movement to new assets, and then repeat. But again, this is all domain identities. And here on the left, you can see a list of tools and techniques that were also part of the methodology that was exposed, from discovery to credential access, execution, and lateral movement. And what's interesting here is that, again, a lot of them are identity focused, and to each and every bullet or item in that list, there is also a detection available in MDI. So this is what we get from looking at Conti. And this is it, I guess. I finished before time. So thank you, everyone.
Excellent. Thank you so much, Shirin. We had a ton of questions coming in, which I think they've all had replies to as well. So yeah, generating a lot of questions based on the content there. So really appreciate that. Okay, so in case we missed any questions, I really don't believe that we have, or if you have any additional questions that you think of over the next couple of days, then yeah, please feel free to visit us at our MDI community or tech community page. So that's aka.ms/MDI community. I'd like to close this webinar off by thanking Shirin for an excellent presentation. And most of all, I want to thank all of you for being part of our excellent community and for joining these webinars so fastidiously when we do publish them. So really appreciate it. We love the interaction. We love the feedback. So yeah, we hope to see you the next time. I will post the links that have been referred to throughout this webinar again back into the chat, and then I will close it off. So thank you so much, and we'll see you soon.